Falcon 9 Block 5. Falcon 9 Block 5 is a partially reusable, human-rated, two-stage to-orbit, TSTO, medium-lift launch vehicle, MLV, designed and manufactured in the United States by Space Exploration Technologies Corp., commonly known as SpaceX. It is the fifth major version of the Falcon 9 family and the third version of the Falcon 9 full-thrust, FT. It is powered by 10 Merlin 1D engines burning rocket-grade kerosene, RP1, and liquid oxygen, LOX or LOXygen. A reusable launch vehicle has parts such as rocket stages, fairings, boosters, or rocket engines that can be recovered and reflown, while carrying payloads from the surface to outer space. Reusable launch vehicles do not need to make these parts for each launch, therefore reducing its launch cost significantly. However, these attractive benefits are diminished by the cost of recovery and refurbishment. Partial reusable launch systems, in the form of multiple stage-to-orbit systems, have been so far the only reusable configurations in use. Falcon 9 Block 5, Falcon Heavy and New Glenn are the only orbital rockets to reuse their boosters. Human rating certification, also known as man rating or crew rating, is the certification of a spacecraft or launch vehicle as capable of safely transporting humans. There is no one particular standard for human rating a spacecraft or launch vehicle, and the various entities that plan to launch such spacecraft specify requirements for their particular systems to be human rated. A two-stage to-orbit or two-stage rocket is a launch vehicle in which two distinct stages provide propulsion consecutively in order to achieve orbital velocity. It is intermediate between a three-stage to-orbit launcher and a single-stage to-orbit, SSTO, launcher. At liftoff, the first stage is responsible for accelerating the vehicle. At some point the second stage detaches from the first stage and continues to orbit under its own power. An advantage of such a system over single-stage to-orbit is that most of the dry mass of the vehicle is not carried into orbit. This reduces the cost involved in reaching orbital velocity, as much of the structure and engine mass is ejected, and a larger percentage of the orbited mass is payload mass. An advantage over three or more stages is a reduction in complexity and fewer separation events, which reduces cost and risk of failure. A medium-lift launch vehicle is a rocket launch vehicle that is capable of lifting between 2,000 to 20,000 kilograms, 4,400 to 44,100 pounds, by NASA classification, or between 5,000 to 20,000 kilograms, 11,000 to 44,000 pounds, by Russian classification of payload into low Earth orbit, LEO. An MLV is between a small-lift launch vehicle and a heavy-lift launch vehicle, HLV. MLVs comprise the majority of orbital launches as of 2025. When launched with an expendable first stage, Falcon 9 Block 5 has the capacity of a heavy-lift launch vehicle, 22,800 kilograms, 50,265 pounds. Rocket Propellant 1, or refined petroleum 1, and similar fuels like RG-1 and T-1 are highly refined kerosene formulations used as rocket fuel. Liquid-fueled rockets that use RP-1 as fuel are known as kerolox rockets. In their engines, RP-1 is atomized, mixed with liquid oxygen, and ignited to produce thrust. Developed in the 1950s, RP-1 is outwardly similar to other kerosene-based fuels like Jet A, or Aviation Turbine Fuel, ATF, also abbreviated after, and JP-8, for Jet Propellant 8, used in turbine engines but is manufactured to stricter standards. While RP-1 is widely used globally, the primary rocket kerosene formulations in Russia and other former Soviet countries are RG-1 and T-1, which have slightly higher densities. Compared to other carrier rocket fuels, RP-1 provides several advantages with a few trade-offs. Compared to liquid hydrogen, it offers a lower specific impulse, but can be stored at ambient temperatures, has a lower explosion risk, and although its specific energy is lower, its higher density results in greater energy density. Compared to hydrazine, another liquid fuel that can be stored at ambient temperatures, RP-1 is far less toxic and carcinogenic. The main changes from Falcon 9 Block 3, the original Falcon 9 full thrust, to Falcon 9 Block 5 are higher thrust engines and improvements to the landing legs, along with numerous other small changes to streamline recovery and reuse of first-stage boosters and fairing halves and increase the production rate. Each Falcon 9 Block 5 booster is designed to fly 10 times with only minor maintenance between launches and potentially up to 100 times, 32 landings today, with periodic refurbishment, while fairing halves have been recovered and reflown countless times. In 2018, Falcon 9 Block 5 succeeded the transitional Falcon 9 Block 4 version. The maiden flight of the Falcon 9 Block 5 launched the satellite Bangabandas Satellite 1, BS-1, on May 11, 2018. SpaceX 15th Commercial Resupply Services Mission, CRS-15, also known as SPX-15 mission, on June 29, 2018, was the last task to be launched on a Falcon 9 Block 4 rocket, completing the transition to an all-Falcon 9 Block 5 fleet. The Falcon 9 Block 5 design changes are principally driven by upgrades needed for NASA's Commercial Crew Program, CCP, and National Security Space Launch, NSSL, requirements. They include performance upgrades, manufacturing improvements, and increase the margin for demanding customers. The Commercial Crew Program provides commercially operated crew transportation service to and from the International Space Station, ISS, under contract to National Aeronautics and Space Administration, NASA, conducting crew rotations between the expeditions of the International Space Station program. SpaceX began providing service in 2020, using Crew Dragon 2. NASA has contracted for 14 operational missions from SpaceX, ensuring sufficient support for ISS through 2030. National Security Space Launch is a program of the United States Space Force, USSF, intended to assure access to space for United States Department of Defense, DoD, and other United States government payloads. The program is managed by the Assured Access to Space Directorate, SSC, of the Space Force's Space Systems Command, SSC, in partnership with the National Reconnaissance Office, NRO. In April 2017, SpaceX Chief Executive Officer, CEO, Elon Musk said that Falcon 9 Block 5 will feature 7 to 8% more thrust by upgrading the engines from 780 kilonewtons, 176,000 pounds force, to 850 kilonewtons, 190,000 pounds force, per engine. Falcon 9 Block 5 includes an improved flight control system for an optimized angle of attack on the descent, lowering landing fuel requirements. For reusability endurance. Expected to be able to fly 10 times with only minor maintenance between launches, achieved on May 9, 2021. Potentially fly up to 100 times with periodic refurbishment, 32 landings as of 2025. A reusable heat shield protecting the engines and plumbing at the base of the rocket. More temperature-resistant cast and machined titanium grid fins. A thermal protection coating on the first stage to limit re-entry heating damage, including a black thermal protection layer on the landing legs, raceway, and interstage. Redesigned and requalified more robust and longer life valves. Redesigned composite overwrapped pressure vessels, COPV 2.0, for helium, to avoid oxygen freezing inside the structure of the tanks that lead to rupture. A composite overwrapped pressure vessel, COPV, is a vessel consisting of a thin, non-structural liner wrapped with a structural fiber composite, designed to hold a fluid under pressure. The liner provides a barrier between the fluid and the composite, preventing leaks, which can occur through matrix microcracks which do not cause structural failure, and chemical degradation of the structure. In general, a protective shell is applied for shielding against impact damage. The most commonly used composites are fiber-reinforced polymers, FRP, using carbon and Kevlar fibers. The primary advantage of a COPV as compared to a similar-sized metallic pressure vessel is lower weight. COPVs, however, carry an increased cost of manufacturing and certification. In 2016, a SpaceX Falcon 9 rocket exploded on the pad due to the failure of a COPV inside the liquid oxygen tank. The failure resulted from accumulation of frozen solid oxygen between the COPV's aluminum liner and composite overwrap in a void or buckle. The entrapped oxygen can either break overwrap fibers or cause friction between fibers as it swells, igniting the fibers in the pure oxygen and causing the COPV to fail. A similar failure occurred in 2015 on CRS-7 when the COPV burst, causing the oxygen tank to overpressurize and explode 139 seconds into flight. For rapid reusability. Reduced refurbishment between flights. A set of retractable landing legs for rapid recovery and shipping. The octaweb structure is bolted together instead of welded, reducing manufacturing time. Since the debut of Falcon 9 Block 5 carrier rocket, SpaceX has continued to iterate on its design, manufacturing processes, and operational procedures. Among other changes, the initial Falcon 9 Block 5 boosters did not have the redesigned composite overwrapped pressure vessel tanks. The first booster with COPV-2 tanks was Booster B-1047 on the ES-HALE-2 mission on November 15, 2018, and the second booster using the COPV-2 tanks was CRS-16, B-1050, which had its first launch on December 5, 2018. The booster B-1050-1 experienced a grid fin hydraulic pump stall on re-entry. This caused the first stage to go into a roll after the re-entry burn. It failed to reach landing zone 1, LZ1, but recovered enough to achieve a water landing off Cape Canaveral. Shortly after the landing, Elon Musk stated the booster appeared to be undamaged and was being recovered. After recovering the booster, it was found to be unable to fly again, and was scrapped for parts. Later Falcon 9 Block 5 boosters are also easier to prepare for flight, so SpaceX prefer to retire older boosters by assigning them to expendable missions when possible. A pressure relief valve was added to the grid fin's hydraulic system following a stall that resulted in a landing failure in 2018. Similarly, after a booster was damaged at sea in 2022, much of the fleet was upgraded with self-leveling landing legs. These legs help ensure the booster can be properly secured to the octograbber, even in suboptimal sea states. To improve the carrier rocket's performance, SpaceX has also tweaked throttle settings and separation timings. SpaceX CRS-18, also known as SPX-18, featured a Falcon mission extension kit to the standard second stage, which equipped the second stage with a dark painted band, for thermal control, extra COPVs for pressurization control, an additional pyrophoric TEA, TEB, ignition fluid, triethylaminium, triethylborane, also called triethylboron. A substance is pyrophoric, from ancient Greek, pyrophoros, fire-bearing, if it ignites spontaneously in air at or below 54 degrees Celsius 129 degrees Fahrenheit, for gases, or within 5 minutes after coming into contact with air, for liquids and solids. The upgrades afforded the second stage with the endurance needed to inject the payloads directly into geosynchronous, GEO, or high-energy orbit, HEO, where the second stage needs hours after launch. Based on mission requirements, they are medium coast and long coast kits, in other words, the number of helium bottles for pressurization and added batteries for power and other hardware to make sure that the fuel and stages systems operate as long as needed. The Transporter 7 mission marked the debut of a second stage with a Merlin 1D vacuum engine with a shorter nozzle extension designed to accelerate production and reduce costs. Unlike the first stage, the second stage on the Falcon 9 is not reused. This variant sacrifices 10% thrust in exchange for a 75% reduction in material usage, primarily the rare metal niobium. As a result, SpaceX can triple its launch frequency using the same amount of this critical resource. Due to its reduced performance, this nozzle is exclusively used on missions with lower performance requirements. The nozzle of the Merlin vacuum series of engines developed by SpaceX for the upper stage of its Falcon 9 rocket is made from AC-103 niobium alloy. Upper stage nozzles are much bigger than the comparable booster as they operate in near vacuum where the plume expands against less atmospheric pressure. The NASA certification processes of the 2010 specified 7 flights of any launch vehicle without major design changes before the carrier rocket would be NASA certified for human spaceflight, and allowed to fly NASA astronauts. So, the NASA CCP human rating standards require that the probability of a loss on ascent does not exceed 1 in 500, and that the probability of a loss on descent did not exceed 1 in 500. Next, the overall mission loss risk, which includes vehicle risk from micrometeorites and orbital debris while in orbit for up to 210 days, is required to be no more than 1 in 270. Maximum sustained acceleration is limited to 3 g. The Falcon 9 Block 5 design launched astronauts for the first time on May 30, 2020, on a NASA-contracted flight, Crew Dragon Demo 2. This was the first crewed orbital spaceflight launched from the United States since the final Space Shuttle mission in 2011, and the first ever operated by a commercial provider.